Hey everyone, we are going to finish up our unit on weather by talking about lightning. So on page 13, and you can fill it out on your table of contents, we're going to talk about lightning. So again, this is page 1. Page 3 we had the water cycle. Page 5 is the atmosphere. 7 is humidity. Fronts is page 9, storms is page 11, and we are now on page 13. So down here on the bottom right, I am going to put page 13. Now if you are missing any of these pages, you can watch the video from the previous one and write it down. So I'm going to be checking these just to make sure that they're done and you get some easy points. So we are going to start by setting up our Cornell notes. So let's draw our line down the side and across. Got the section up top where you put your name in case you lose your notes. And the date, which is 11/16/21. And our title for today is Lightning. And our essential question, or EQ, is why does lightning happen? And that's kind of an interesting question, and it's a really spectacular thing that we get to see it, and it's pretty interesting. And I mean, a lot of studies are still happening about it, but from what we know, let's talk about some basic parts of an atom. So we're going really basic. There are 3 parts that we're going to talk about. There is a proton, a neutron, and the important one for us in this case is an electron. So the protons, they are positive. Neutrons are neutral, meaning they don't have a positive or negative charge, and electrons are negative. Okay, so this is important for the next part, which is charge. The charge of anything is going to depend on the electrons. So it depends on the electron balance. So let's draw a picture. So we'll have a circle here and a circle here. So I'm going to put 3 plus signs in this one and 3 plus signs in this one. Those are going to represent our protons. Those are positive. The protons aren't going to move. It's the electrons. The electrons are on the outside of an atom, and they're just kind of spinning around or moving around. They're free to move from one atom to the next. And so we're going to just draw in, let's say I have 10 on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons here. That is way more than my number of protons. It's kind of ridiculous. This is going to have a negative charge. This one, let's say I just put 2 electrons. This, it has more protons, so there's 3 of them, and there are only 2 electrons. This is going to have a positive charge. Now, if they are equal, then it's neutral. It doesn't have well, I guess technically that would be the charge. It's neutral. But it doesn't have a positive or negative charge. Okay, so let's keep that in mind. One more thing I want to add to this actually is if I have a positive, it's a plus sign, and a negative, they are going to attract. They want to go to each other because they want to be neutral. They want to cancel each other out. If I have a positive and another positive, that is not going to put them closer to being neutral. That is going to put them further away. So they're actually going to be pushed away from each other. Same for a negative. They're repelling each other. They want to be closer to a positive or further away from a negative. So that's what they're trying to do. Okay, so that leads us to our next string is an electric discharge. So an electric discharge is this movement of electrons in order to be balanced. It wants to be neutral. And so let's put that. Movement of electrons. Oops. Electrons. In order to be balanced or neutral. All right, let's draw another picture. Yes, so good. All right, we're going to draw 3 more positives, or protons, I'm sorry, 3 more plus signs for our protons. We're just going to keep going through this whole thing. All right, so let's put an equal sign. I'm going to put 10 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons in this one. Let's say I only have 2 electrons in this one. So I have a negative and a negative. This one has way too many electrons, and so it's going to want to get rid of those. And in order to do that, it's actually going to cause this flow of electrons to somewhere else to make it balanced. And so in this case, it's going to be a static discharge. And it's not moving all of the electrons. It's just moving enough of them to become closer to being balanced. And so in this case, I have 10 and 2, which makes a total of 12, obviously. So we're going to divide that in half. So I have 6, 1, 2, 3, 4, 5, 6 on this one. And 1, 2, 3, 4, 5, 6. Yeah, okay. 6 electrons on this one. So they balanced out. But in order to do that, they needed to do this electric discharge, this movement of electrons from one with really high amounts of electrons to an area of low electrons. It's not going to go from here this way. It's definitely going to go from high to low. Okay, and that leads us to lightning. Lightning is just like a ridiculously huge example of this. So this is going to be natural electric discharge. And it's going to be involving, so it's with a, within a cloud or between a cloud and the ground. Sorry, getting a little sloppy. So it can happen from cloud to cloud or even within a certain cloud, but it can also be from the cloud to the ground. It just depends on where this imbalance is and where the closest area that it can discharge those electrons to. So something really cool that happens with lightning is actually thunder. So thunder Thunder is caused by this superheated air. So superheated air, it's actually causing it to explode outward. And that causes the sound that we hear. So superheated air causing it to explode outward, making noise, making a loud bang. Let's do that. A loud bang. And it's roughly 50,000 degrees Fahrenheit. Sorry. And that's, what was it, 5 times the temperature of the sun, or the surface of the sun. So stupid hot. And it could be hotter. It could probably be a little cooler depending on the number of, or like the voltage. Obviously, some lightning strikes are a lot bigger than others. And so that can vary. But in any case, it is because of that superheated air. It got so hot that when things heat up, they expand because they have more energy. It takes up more space really quickly, expanding, and that's how they get the noise. So that's super cool as well. We're going to do a bunch of cool experiments with this, so write that down, and I will see you guys later.